when you talk about volume in math, you're talking about how much space something takes up. And when we talk about math, and when we talk about volume in math, the way that we tell somebody how much space something takes up is we use what's called cubic units. Yes. Okay. And cubic units are all relative to what type of cube you're talking about. First of all, what is a cube? You better understand what makes something a cube. Is that, Grace, it's three-dimensional, but what special kind of three-dimensional object? A cube has what special feature? What's the difference between a cube and a box? A box is a three-dimensional thing. It's a rectangular prism. And a cube is a rectangular prism. But a cube is something incredibly special. In that, Gary? Yes, I can touch a box as well. I'm looking for what makes a cube special. What separates it from any other rectangular prism? Eli? Exactly, and that's what you have to understand. Okay, a cube has all equal sides. Okay, now let's start with a small cube, and I'll do the best drawing I can of it. If you were talking about a cubic centimeter, okay, that's a pretty small little shape there. And I'm going to abbreviate it like this, 1 centimeter cubed. And what that means is every side of this shape is a 1 centimeter, has 1 centimeter for its length. I've got it. And this actually is one cubic centimeter. Mine's really not drawn to scale because it's actually a lot bigger than a cubic centimeter. If I can get this bag open. 1 cubic centimeter is this right here. This is an actual cubic centimeter. Okay, not a very big thing, but it is 1 centimeter. Every side on this thing would be 1 centimeter. Okay, and you can get bigger. That's kind of one of our smaller ones. If the thing is 1 inch on every side, that is 1 cubic inch. Again, I can abbreviate it like that. It would be 1 inch by 1 inch by 1 inch. If you had to guess, I wish I had an inch cube, by the way. I don't. And then you can start talking about, for example, if I wanted to ask you the size of my room, okay, we could talk about it in cubic feet. That would mean it's 1 foot by 1 foot by 1 foot, like this. And you're not going to be able to draw a cubic foot on your paper because you don't have enough room, because your paper is only 8 1/2 inches wide by 11 inches long. So you couldn't even get a real live cube out of that. If you tried to draw a three-dimensional one, you couldn't do it. Okay? So this is what we do volume in, because volume has to be three-dimensional. Has to be 3D. Gotta like that, doesn't it? Has a little ring to it, doesn't it? Okay. Now, one way that you can do something to find the volume, let's say I've got this block that is, well, how big does that look? 6 inches? Let's say this is 6 inches by, how long does that look? 12 inches? 12 inches by, let's just make it 2 inches. Say I've got my block. I've got a big block, rectangular prism that looks like this. Now, one way we could do is I could sit here and I could cut it up into blocks and see how many I have. Let's do this. I have 6 inches this way, so I'm going to cut it 6 ways this way. Why? This could get really interesting here in a minute. 12 inches, 12 this way. Let's see. That goes 6 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Then I have to cut it like this. I can tell this is going to get a little tedious here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you're gonna say, man, I'm glad there's a better way to do this here. If I asked you how many 1-inch blocks, how many 1-inch blocks it would take to make this thing that I just made there, and you sat down and counted them, well, one thing you have to remember is there's a bunch you can't see behind these ones here. If I asked you to make a stack of blocks that was this dimension, 6 inches high, by 12 inches long, by 2 inches wide, how many blocks would this take? Well, here you go. Let's do this. I'll number them off. Let's look at the ones we can see. Let's look at just this front face right here. Let's do 1, 2, 3, 4, 5, 6. Oh, let's try that. Oh no! Don't worry, kids. I've got this under control. Let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 blocks in this row right here, right? Then there's another 12 blocks here, 12 blocks here, 12 blocks there, 12 blocks there, 12 blocks there. How many blocks would that be altogether? I've got 6 rows of 12 blocks right here. Anybody 6 times 12?
17.
Okay, there are 72 blocks in just this front row right here. If I stacked 72 blocks up there, I would just have one that's 1 wide, 6 high, 12 long. Okay, but I've got 2 rows of those. I got one that's directly behind it that's exactly the same size, so that's another 72 blocks. So how many, the volume of this shape is, how many blocks did I count up, Michael, altogether?
144.
There are 144 cubic inches. It would take me 144 of those inch by inch blocks to make a shape that is just like this. Okay? If I asked you this question, looking at my room, my domain, my palace.
We get it.
You get it?
No.
If I asked you how many, the cubic feet, what the volume of my room is, now let me give you a little helpful hint here. You can see how many blocks that would be 1 foot tall that are the same shape as the floor tile. That's 1 cubic foot. A floor tile that's 1 foot tall. That's 1 cubic foot. How many blocks would it take if you had, I wish I had one. Do I have something that's about a cubic foot? I don't. One of these days I'm going to get it. No, that's not. It has to be it has to go there. This is it. How about this? Here you go. I do see one. This is close. It's not exactly. It's a little big, but it's close. This is mighty close. It's a little tall and not quite as wide, but this is really close to 1 cubic foot. If I set it on the floor, it's exactly a foot this way, it's a little short this way, and it's a little tall. Oh, it's actually just a little short. It should be just a little bit wider. That would be 1 cubic foot. If I asked you how many of these blocks would it take for you to fill up my entire room, stacked up in a nice neat stack, your guess would be what, Alexa Lutz? I'm taking for a guess. Give me a shot, just give me something. I don't have all day. Huh?
100.
100 blocks. Interestingly enough, Grace?
160.
160 blocks. Nicholas Winkleman?
9,000.
9,000 blocks.
I got it.
I don't know what Nicholas is thinking.
30 times 10.
Yes, Jacob.
600.
600. I'm going to take one more guess and then we'll get down to the bottom of this here. If I can find my pen.
It's on the chalkboard.
Oh, there it is. Gary says
890,000.
890,000. I'm going to guess that's a little high, but wait. Okay, let me give you the gist of my room right here. Here's my room. I'm going to draw it slightly three-dimensional for you.
Where's you?
Well, he's not here just yet. Let me do that again.
He's disappeared.
Maybe you'll be able to see here. Okay, here is this wall, that wall. I'm going to put my little dash line here. This technically would be here's my chalkboard. Here's the chalkboard, the board that I'm writing on is kind of right here. Over there is that corner with the cabinet right there. This right there is actually that wall that has that bulletin board. Here are the windows.
It's so detailed.
Okay. Now, let me give you just the gist here, because Nicholas was on the thing. My room is, if you count the blocks, it is 30 feet, pretty much 30 feet one way by 30 feet the other way. Okay, now, here's the deal. So that means, well, you're getting close, if I went just one layer, 1 foot tall, just one layer right like this, stacked with all those blocks, it would take 30 times 30 of them. It would take 900 blocks just to make it one layer tall. Okay, because it's 900, there's 900 square feet in my room. One layer would be 900, 2 layers would be another 900. However many feet tall my room is, which is actually, well, actually my room is only, I'm going to say 9, let's say 9 feet tall. That means there would be 9 layers of 900. You put 900 down and then you put another 900 on top. It'd be tough when you get to the top because it'd be hard to, you'd have to lay it on the floor. I don't know how you'd stack them all up there, but it would be 900 times 9 layers, which is 8,100 blocks. Yeah, 800,000 is just a little big. Okay. Now, here's what you really need to know for today, though. Rather than counting blocks, we have a little formula that we use. Okay, and it is, I heard somebody say out there, it is LWH. We like to in math abbreviate so we don't have to write it. But L stands for length, W stands for the width, and height is for the H. Okay, 6, 12, and whatever this is. Okay, they're the 3 different dimensions that you have, the length, the width, and the height. Usually, the height, sorry, I should have put this as 3 and this is 6 down here, okay? Generally speaking, the height is how tall the shape is when it's sitting down there. And then the length and the width are usually the longer. The longer one is usually the length, and the width is usually the shorter one. It doesn't matter because it doesn't matter the order that you multiply it, but you'll get the same answer. So if they give you a shape that looks like this, let me see, what do they actually ask us to do for that? Here's one right out of the book. They say, here's a cereal box. By the way, if you look at cereal boxes, it will tell you that the product is measured by weight, not by volume. Do you know what that means and why they say that? Why do they say that? You see what it is, 7, 7, 8, 12, or whatever. You look at almost every cereal box, I think will tell you that. Okay, if you open a cereal box and you flip open this little tabby cap layer thing they have there and you open the box up, a lot of times you will see that the box is really only filled up to right about here of cereal. Okay, well that's because why? Well, cereal is not in nice square blocks. It's usually in these round things or the flakes of something here. And what happens when you carry something that's not quite round or whatever and you shake it up a little bit, it starts to pack in. Okay, so probably at the place, it started out being way up here, but as you move things and shuffle things around, it settles. There's still the same amount of stuff in here, but what the cereal people tell you is that they weigh it. They weigh it by how much weight. So that doesn't matter what the volume is, because the volume can decrease as that stuff gets pushed down, but the weight will be the same. So they're telling you, it says down on the bottom of your box that you're buying 12 ounces of cereal. That's a weight. It's going to weigh 12 ounces no matter how much shuffling around you do. It doesn't. You're not buying this because of the packaging. You're buying by how much is in it. So just know that that's kind of something. Now the book says to do this: estimate the volume, which would mean we're not going to have to deal with the fractions. We're just going to round those. 12 and 1/8 is close to what? So you make this 12 inches. 7 and 7/8 is close to 8, and 2 3/4 is close to 3. So when you find the volume, what I want to see is you draw the picture. You give me the formula, length times width times height, and then you plug in the numbers. 12 times 8 times 3. And it doesn't matter the order you multiply. I can multiply 12 times 8 and get 96. Multiply that by 3, and you get 288. Okay, and please remember, when it's volume, you need to label it accordingly. This is in cubic inches, or if you like, you can do the little inches with the 3 thing there. But you have to remember that labels are important because this, when you see 288 cubic inches, that means you have 288 inches that are cubes. That's not the same as 288 inches. I don't think you can buy 288 inches of cereal. That's just inches is just a straight measurement. If you had a ruler, you could measure off 288 inches. But if you're talking about 288 cubic inches, that means you have 288 of these cubes all together. That's why labels are very incredibly important when it comes especially to volume.